Hey everybody, my name is Kelvin and welcome back to episode 10 of my Learn Python series. Today, we're going to be taking a look at object-oriented programming. This is one of the most important parts of Python because pretty much all of Python is built around objects. If you've paid attention in the last 9 lectures, we've already been using objects in pretty much every single episode. Strings are objects, lists are objects. When you write something like name.lower, or items.append, we're going to be calling a method on an object. The goal of this video is to go over object-oriented programming principles from the ground up. By the end, you should be able to answer a couple questions like, what is a class? What is an instance? What is a method? Object-oriented programming, or OOP, is essential for software engineering. A lot of technical interviews will really test your object-oriented programming skills. Take that from me, as someone who's sat in on many of those interviews before. As always, the course repository is linked in the description, and of course, I recommend watching the earlier episodes before this for the best learning experience. Before we dive in, I have something I'd love to share. Have you ever wondered how the biggest companies in the world organize, sort, and analyze their data? It's from the work of data engineers. Data engineering is the backbone of modern analytics, business intelligence, and machine learning. Data engineers in the US earn around an average of $130,000 per year, with some even making over $200,000 annually. Hi, my name is Kelvin Lin, and I wrote this book because this is something that I wish I had when I first started out. From databases, data warehouses, and real-time data streams, this book will give you a great foundation to launchpad your data engineering career. This is Modern Data, from Ingestion to Production. Available on Amazon, Apple Books, and Barnes & Nobles, so get your copy today. Welcome back. Let's jump straight into Lesson 10. We'll start by creating a Lesson 10 folder like usual. Here, we'll first initialize our exercise file. We'll start with 10-1.py following a regular naming scheme. In this section, I want to help you understand what an object is without introducing the concept of classes just yet. An object is simply a value in memory. It contains data, and it has behavior. The behavior is exposed through things called methods. A method is essentially a function that belongs to a specific object. A rule of thumb is when you see a dot or a period, you should think, I'm accessing something that belongs to an object. That something could be a method, or it could be a data. Data stored on an object is simply called an attribute. We're going to review strings and lists because you already know them. We'll call methods on them and observe what happens. We'll start with a string. Text is equal to hello world. We'll print this. Strip is a method on a string. It'll return a new string with white space removed from start and end. Here, we know we're calling a method because of the period right here. We can also do a lower method, which we can call with the lower method, like that, and we can print that. Print cleaned, and we'll print lowered. When you run this, notice that the original text did not change. And then we'll also print text. And we'll run this. The thing to notice here is that the original text did not change. We can see that it's printed up here. We'll see that it was printed first using the print function and printed down here after the transformations. But the thing is, if you notice right here, the text string has not changed. That's because strings are immutable. Methods like strip and lower will return new strings instead of modifying the original. Specifically, the string methods like strip and lower are designed to return new strings instead of modifying the original. Let's take a look at a list. I have a list of names with my name, And we'll have a John in here. We can print the names. And now here, we'll call the append method. And we'll append a name, Noah. And then we can print this. We can do this because lists, again, are mutable. We can run this. And we'll see that our original list has been modified. And we'll see that our original list has been modified. That's because lists are mutable. They have different behavior than strings. It's still the same idea though. We have an object, and you are calling a method that belongs to that object. Let's dive into the next exercise. We'll create a file called 10-2.py. And here, I want to cover your first class and your first instances. What is a class? A class is simply a blueprint. It defines what kind of objects you can create and what they can contain. An object created from a class is called an instance. The words object and instance are often used interchangeably, but it helps to be precise. The class is the definition. The instance is the actual object you create. We'll start with the smallest possible class. In Python, an empty class uses pass. Pass basically means to do nothing. It's a placeholder, so the class block is valid, and the code will work. We define a class using the class keyword here, and we'll call our class here person, and then we'll simply just pass this. This defines a class named person. This does not create a person object just yet. It only creates the blueprint. To create an instance of class, you have to call the class like a function. So if we had a variable called p1, we can set it to a new instance of person, like so. And we can have a p2 is equal to another instance of person object. And then we can print this, p1, print p2, and print type of p1. And when you run this, we should expect to see that p1 and p2 are separate objects. And the type of p1 will show that p1 is of type person, because it is an instance of the class person. We run this, and we can see a person object at these memory addresses, and our type of p1 is a person. Let's give these objects data now. Data stored on an object, if you recall, is called an attribute. We can assign attributes using dot notation. Get rid of these. Dot notation is our period right here. We can do p1.name is equal to Calvin, and we can do p1, my age is, say, 30. Not at my actual age, but it's just an example. And we can set attributes on p2 as well. And we can have John, and let's say John is 60. Oops. We'll keep these as integers, actually. Notice that these attributes can be of any type. And let's print these. Again, we'll use dot notation. Again, we'll use dot notation to access the attributes. And we see that we've successfully printed what we expect to see. This works, but it has a real problem. Python will not stop you from forgetting an attribute. You could create a person and never set any kind of age. Then later when you try to read p.age and your program crashes with an attribute error. That's why classes almost always define something called an initializer method. The initializer method will give you consistent creation process. The special method here is defined like this. 2 underscores, init, and another followed by another couple underscores. And init here is a special method that will run automatically when you create a new instance. It's a method that Python knows to call for you. Say we wanted to create a person object with a name and an age, like down here. We'd have to do something like this. Pass in self. The first parameter of every instance method is self. Self is the current object. It's basically how you refer to this person inside the class. We can rewrite person so that the name and the age are required when you create an object. So we'd have to do something like this, self, comma, name, comma, age. Oops, we need a def right here. And we'll set self.name is equal to the name parameter that we pass in here. And self.age is equal to the age parameter that we pass in. And now here, we've successfully set the attribute of this person object to whatever you pass in for name. In this case, Kelvin and 30. So now that we have our constructor, every person is now guaranteed to have a name and age because init runs every time a person is created. The point of that is to make your object predictable. Let's add a print statement here and let's demonstrate that. And we're going to create a person object with John, and he's 60. And now when we run this, we'll get exactly the same thing. But now here we can see that we created 2 separate person objects and we set the attributes name to Kelvin 30 and John 60 within each separate person object. Let's jump into exercise 3. In this exercise, I want to cover that methods will define behavior. In this exercise, I want to cover methods. Methods, as we've established, define behavior for your objects. A method is a function that's defined within a class. The reason methods matter is that behavior should live with the data it belongs to. If you have a person object like before, it makes sense for the person object to know how it introduces itself. It also makes sense for the person object to know how to update its own age. Let's grab our class from before, right here. I'll pop it into 10-3 right here. And we'll add 2 methods. 1, introduce, and 2, birthday. Introduce will print a sentence using the object's attributes, while birthday will update the object's age by 1. The idea here is when you call p1.introduce, Python will automatically pass p1 into the method as self. So inside introduce, self refers to p1. In order to define a method, we use def. Make sure that this def is indented within object person. And we'll call our method here, introduce, and we'll pass in a parameter of self. Now this method will have access to all the attributes within its own person object. So we'll have a print statement in here that will use our name and age attributes. Hi, my name is, and then we'll have self.name. And I am some age, self.age. And we've successfully here, we've defined a method for this class. And let's define another method called birthday. Also takes in itself. And we'll set self.age is equal to whatever age plus 1. And we'll pop down here and we'll initialize our object. So person is Calvin. And now we can call our methods on the object. So let's call our introduce method like that using dot notation, p1.introduce. Print that. And now you can see that it'll take the attributes that we defined here and print them in this statement. We're going to do the same thing with p1.birthday. And then let's introduce ourselves again. Because our birthday method here will not print anything, but we know it's going to run in the back. So if we just had this, we'll still only get this print line. But if we call print p1.introduce again, we should expect to see, hi, my name is Calvin, and I am 31 now. And that's what we get. The key idea here is objects can hold data and provide the functions that act on that data. The code stays organized because you don't just have random helper functions everywhere for behavior for a person. The person class will own that specific behavior. Let's work on an actual real-world example. Or let's jump into our next exercise. Create a file called 10-py, and we'll pull our class definition into the new file right here. In this exercise, I'd like to jump into a harder example. We'll create a list with 3 objects. 3 person objects, and we'll give them different attributes. So we'll keep one of me, person, John, 60, and person, Ava, 25. And now I want to iterate through this list and introduce everybody. So this would be pretty easy if we did a for loop for person in people. And we can loop through, grab each object, and call the introduce method on each one of them. So if we run this, we'll see 3 different print statements, all calling their own version of introduce, using their own attributes. So if we call this, we'll get 3 similar statements, but we'll have different attributes in each corresponding to each person object. Now, what if we wanted to update everyone's age? Same thing. For person and people, we simply just call the birthday method. And then we'll just have everyone introduce themselves again. And now here, we'll expect to see, hi, my name is Calvin, and I'm 31, 61, and 26. We've designed our methods so that we can update our object's end state. There's a lot more things I'd like to cover in object-oriented programming, and like functions, this is fundamental for your learning, so I'm going to split this episode up into 2 parts. Here, we'll save our progress using our same Git workflow, git add, sometimes the terminal is wonky, git add, lesson 10, git commit, and we'll have our message be git lecture 10, object-oriented programming part 1, and we'll push this, and we'll have saved our progress. From this video, you should be clear on what objects are. because you've already used them through methods like strip and append. You should understand that a class is simply a blueprint, and an instance is the object that is created from that blueprint. You should understand that attributes are simply data that's stored on that object. You should understand that methods are functions on the class that operate on the object, and that self is how the method refers to the current instance. You should also understand what init does and why it exists. Remember, it sets up the object so every instance can start in a consistent state. In the next object-oriented programming video, we'll build on this by covering more class features than you'll see in real life. Thanks for watching, and I'll see you guys soon.